Welcome back. This is the beginning of Unit 8, Week 8, Lecture 17, Part 1. This lecture is going to be broken down into two parts. We're going to look at some more polymer addition reactions. In the last lecture, in Lecture 16, Part 2, we took a close look at polymer addition reactions using ethylene as the monomer, and we looked at different reaction conditions to give different types of polyethylene, high density and low density. Now we're going to look at the different types of properties you get when you change the monomer unit itself. So here's 4 common monomers that are used in addition polymerization reactions. Ethylene, of course, we've already looked closely at. And here's 3 other very, very common monomers used in addition reactions. So I'm going to scoot this over so you can see a little bit better. This particular monomer is called vinyl chloride, and you can see that the hydrogen on the ethylene has been replaced with a chlorine atom, a chlorine atom. So we say the hydrogen has been substituted with a chlorine atom. That gives us a new monomer. This is another common monomer called propylene, and again a hydrogen on the ethylene molecule has been substituted out for a methyl group. And here this one's called styrene. This particular monomer is called styrene, and it looks very much like ethylene except for a phenyl group has been substituted out for the hydrogen. Polymers made of vinyl chloride are called polyvinyl chloride, or you've probably heard it more familiar with the abbreviation PVC. That's polyvinyl chloride. Propylene is polypropylene, and it's abbreviated PP. And styrene is polystyrene. You've probably heard of polystyrene as well, PS. So ethylene is PE, but you know we had the high density, which was HDPE, and the low density LDPE. So two different polymers from the same monomer, and then we can have PVC, PP, and PS. So let's just take a closer look at the addition reaction for polyvinyl chloride. It looks very much like the addition reaction for polyethylene. In this case, we have N number of monomer units. We've added an initiator. In this case, they put it over the arrow instead of making it a reactant. Sometimes that's done because it's such a small amount of the initiator compared to the actual amount of monomer. And you end up with N units of this monomer unit. And again, you can see that the double bond has gone away. And on one end, it's going to be bound to the R, and on the other end, it's just going to be bound to more and more monomer units. So it looks very similar except to the polyethylene, except for the polyvinyl chloride, or PVC, has a chlorine atom that is in place of one of the hydrogens. Now, when you make the monomer polyvinyl chloride, you also have, just like with the polyethylene, you can get different applications depending on if there's branching or not. The same thing is true with polyvinyl chloride, but the main difference that occurs in the different polymers is the arrangement of the individual vinyl chloride molecules. The most common arrangement is what's called head-to-tail, head-to-tail, and what they're referring to is the location of the chlorine atom. In this case, the chlorine atom, it's a pretty regular pattern. It goes chlorine, then hydrogen, chlorine, then hydrogen, chlorine, then hydrogen. So the the head, and a lot of times the chlorine is considered the head of the molecule, and the hydrogen the tail of the molecule. So head to tail, head to tail, head to tail arrangement, where I'm sorry, my bad. In this case, the head is the hydrogen and the tail is the chlorine. The red is the hydrogen and the blue is the tail, obviously. So anyway, head to tail. So this is starting right here. The front of the molecule, the head of this monomer unit, which would be from here to here, is reacting with the tail right here of this monomer unit. Okay, so that's a very regular pattern, and so these types of polymers can pack together tightly. This is head to tail, tail to tail. where the molecules are reacting in such a way that there's two chlorines together, two hydrogens together, two chlorines together. Chlorine atom is much bigger than the hydrogen atom, and it's electronegative, so it takes up more space and gives us a less regular type of arrangement. And then sometimes, depending on which you can get random, some head to tail, some head to head. The head to tail arrangement is the stiffest type of PVC because of the tighter packing. And so this, packing. So this type is the type of PVC that you see in drain pipes. You know, you've heard PVC pipes. You've probably even seen them before. Drain pipes. Credit cards are made out of PVC with this type of head-to-tail arrangement. The head-to-head, since it doesn't pack, it's a softer, more flexible type of a plastic. This one's more flexible. And this is the type of material that might be found in waterproof boots or garden hoses. That's sort of an application, more flexible. And also, an even more flexible, you can get an even more flexible PVC is to take either one of these and add to them what's called a plasticizer. And a plasticizer, plasticizer gives even more flexibility to the plastic. A plasticizer is normally a small organic molecule that just gives a little bit more space, a little bit more flexibility to the plastic. But there's problems with plasticizers, which you'll read later, which some of them have been found to be carcinogenic, okay, because they can leach out of the plastics. But nevertheless, PVC is a common plastic to have a plasticizer added to it to give more flexibility. And the plastic wrap that we looked at in the previous lecture was a polyethylene plastic wrap, but there's another type of plastic wrap, for example, Saran wrap, which is actually PVC with a lot of plasticizer added to it. Okay, so anyway, there's different ways to get different properties by the monomer units forming in a regular pattern or a regular pattern but with the large chlorine atoms next to each other or random. And then finally, another way to get different properties in your particular plastic is to add a small organic molecule to add more flexibility. But there's some issues with that. You can take a look. The 3D Chem site also has polyvinyl chloride, PVC, and also polypropylene. Polypropylene is another plastic that is the propylene monomer, which is in your book. You can read about that one.